No-code solutions to create rich visualizations for data exploration still poses many challenges. On today's episode of the AI Ascent podcast, we will be talking with Chenglong Wang about Data Formulator 2, which makes significant contributions in this area. Welcome to the podcast, Chenglong.
Hello. Yeah, thanks for the invitation, Luke. I really like to talk about the AI and how the AI will impact the data analysis landscape.
Awesome. So first, let's get into some background questions about you. Could you explain your background, specifically which university degree you have and where you're working now?
Yeah. So I'm now a researcher in Microsoft Research. I'm mostly working on the intersection between AI and HCI. The main goal right now is to develop like AI-powered tool to make it possible to make data analysis, data visualization much easier, with a focus on building the new interaction experience that goes beyond the traditional the data analysis tool, but also going beyond the current status of like just chat-based, text-based interaction. So yeah, I did my PhD in University of Washington, where I mostly focus on program synthesis, just how to leverage program language techniques to make it easier for people who don't write program, but to enjoy the joy of the program to solve their problems.
Interesting. And so how did you get into this type of work at Microsoft?
Yeah, so I think just even before AI, there is a stream of work called like program by example, program by demonstration, and program by natural languages. That's mostly leveraging, for example, semantic parsing and program synthesis technique to generate code from no-code specifications. Like the user will provide demonstration to you of a task, and you're trying to generalize the task into a program that can solve the problem. And yeah, traditionally, I think there's a lot of scalability issue. And for example, if the user specification is noisy or the task they don't solve is too complex, it's very hard for the computer to any algorithm to synthesize a program to solve the problem. And as AI comes in, it's adding a new recipe essentially. Just like, okay, you can see the large language model make it much easier for people to just have a high level specification in terms of like text, right? Or even now with images or like some composition of video or something. So yeah, it's adding a new modality for the model for the computer to generate program. But right now the challenge, okay, now the computer is much better, but how can the user to better specify the intent, right? Now the user wants to solve more complex stuff. And essentially now our research into, okay, now with the new technology where experienced data analysis can leverage to solve the problem, how can we leverage this technique for like no coder or people who are more like data focused, not have traditional programming background, to take advantage so that they can describe the intent and to communicate what they want and also understand what the AI is generated. So this naturally become this area of like, it's typically called AI for code, but also like AI for code and also on the human AI interaction side.
And did you present this paper at a conference?
We have an earlier version presented in VIS 2024, and a new version will come out soon. So keep looking.
Yep. And how did you come up with this idea for this specific paper?
Yeah, so this is also a continuation from our previous exploration. In the past, like natural language, I mean, of course, we all know, right? For programmers, us we all use Copilot, use Cursor to just able to specify high-level intent and get a bunch of code. And if the code is looking good or not looking good, we can actually modify it and ask follow-up questions. But for like data analysis, data analyst, this is a much harder problem. And so in our previous data formulator paper, we're essentially trying to compose program by example technique together with program and natural language together. At that time, we were working with essentially trying to say, is it possible to constrain the problem in a smaller kind of like task domain so that users can achieve more reliability? So essentially, AI can generate the solution in a very reliable way. So the user who don't know program don't have to look into what AI generated to disambiguate to fix it. And at that time, we are limited into can we just have LLM to generate those column-wise computation? For example, extracting a month from a date, this kind of simple stuff, and then at the same time leveraging some of the complex transformation like pivoting to program by example. But from our user study at that time, we realized, okay, for a complex task, it is really hard for the user to specify in one turn. like even we wanted the natural interface to be as simple as possible. It's very hard to provide one example to demonstrate intent. It's very hard to provide one sentence for the user to like to specify what they want. But then, okay, so if not one turn, then it means multi-turn. But multi-turn is pretty natural, right? If you think about conversation, we can talk to A, and then AI responds. When we say B, and then AI responds. But the problem now for the for non-programmers is that they don't necessarily always know how to prompt and how to interpret result. So we're thinking, is it possible to design a way that like have an iterative process, like similar to chat, but also centered around like data and visualization, so that the users can have those continuous conversation with AI to be able to see something incrementally, and then be inspired by the current result to either suggest a fix or suggest new analysis, right? And this becomes essentially now in order to support this like multi-round interaction in the non-chat way, we're imposing two main challenges. One is that how can we have an interface that allow users to communicate their intent, assuming that people don't always know how to write a perfect prompt? And the second thing that whenever there is an AI response, is it possible to present not just the original code, but present something that user can interpret, understand, and also can ask follow-up questions? And this essentially comes into two main design in data formulator. One is a multi-modality user interface, which allow users to do some like drag and drop together with some supplemental natural language. At the same time, it's a threading mechanism where the user provide interaction. It transforms the data, present the visualization and new data for the user to interpret analysis to inspire them for the next round of interaction. So essentially this generally become this like multi-modal iterative approach for the user to specify and analyze data.
I see. And so what do you use for the backbone of this model? What type of LLM are you using?
Yeah, so the backbone, we initially start with the Codex model, and then 3.5, and there's a kind of like tricky period where GPT-4 comes out, but it's very slow. So at that time, we were kind of decide, okay, just for it's better to give a wrong result sooner than have the user to wait forever to not be able to see, and then they're kind of sort of scared. So at that time, we were still using a 3.5, but now with the GPT-4o is much more reliable. So yeah, so we're able to use GPT-4o. And actually, interesting aspects like in data formula, there's not just one AI agent. The main data transformation and synthesis agent is GPT-4o, which requires ability, but also some smaller tasks. For example, just help to do a smart sort of the month. One example is that when you create a chart has April, February, something, right? It always sorted April first if it's just by alphabetic. So we're actually able to leverage a small model to do this kind of smaller, kind of tidy, clean-ish task. So we are essentially now kind of combining both smaller models and larger models. Even more ideal, I feel in the future, we may also incorporate some like actual small language model for somewhat smaller tasks for lower latency. Yeah, but the backbone is GPT-4o.
I see. That makes sense. So yeah, sounds like you've been working on this for quite a while, given that you were using 3.5 and even before the 3.5. I suppose that was with Data Formulator 1. Is that correct?
Yeah.
I see. Makes sense. And so so we were discussing how you're able to use this these LLMs in order to do this data visualization. Can we go into some of the challenges for users and models when providing a text-only prompt for complex visualization tasks?
Yeah, so actually it's very interesting, right? The challenge for people to use just text to describe a chart is often that people are sometimes users are so they sort of know what they want, but they don't necessarily know how to communicate that using text. So for example, right now I have a thought about, I want to create a chart to compare the energy of two cities, right? Like over time, I may say, yeah, energy over time, right? But then in the fact that in my mind, I'm thinking about a line chart. I'm thinking about, okay, maybe I use color to distinguish the city. I may have x-axis of time, and also maybe the time is aggregated because my data has like too many dates, right? So just using text, on the one hand, people want to stay extremely high level, which means, okay, the AI will have to guess what you're thinking about, which it often leads to, okay, like rounds and rounds of disambiguation. The second is that it's just quite verbose for you to type all the designs in on a line chart. Okay, what am I missing? What's the next? Okay, x-axis should be something, and then in the end, you're writing a small paragraph. Is that already kind of like quite a lot of effort, even just to communicate, right? And actually the biggest advantage for going beyond text is that traditionally there is a very good UI for specifying chart. For example, like if you're using Tableau, right? That's one of the magic where you can just like drag like the fields to the axis, and it knows what's the configuration to be. And the drag, you don't need to type anything. And so essentially, we're thinking about, is it possible to just like have some interface that, well, on the one hand, can help user think what they're describing. So because if you essentially, you can think of the UI is kind of like a form, I would say. It has a bunch of slots, right? And then when the user see, oh, those are slots I need to fill in order to specify it to make my task very concrete. So the user then start to reflect a little bit better. Even something is possible, something not possible, they can think a little bit better. At the same time, like having a UI for user to just do a drag and drop is much better than just filling a form. If we're just using a form, it's still kind of verbose, right? But at the same time, like a traditional UI has a limitation that it has to be a data that is already have all the fields available. You can only, for example, map date to x-axis if date is already a field. What if I want to map month? Then I have to manually create a field month and then before mapping. But with natural language, the benefit is that people can go beyond specification. They can put a date here and then describe how they want to extract date, and it's going to be aggregated based on something or not. So essentially combining those two kind of like overcome the limitation. On the one hand, it's quite flexible. It still have natural language elements here. On the other hand, the structured input, having those like what we call view encodings, from mapping from fields to view channels, has a way to help user to form the thought on what a chart looks like, and yeah, essentially make it much better to describe. And the benefit of a more concrete description is that they don't, on the one hand, the AI return result is generally more reliable. I mean, even if it goes wrong, it's wrong within a framework with their framing. It's not going to go super wild, something completely different. On the other hand, it just really helps the AI. I mean, when the specific more concrete, it can essentially spend more of the code generation aspect on the specific design. Yeah, and so in the end, as you can see, if you just chat in a raw chat, you often multiple rounds of disambiguation or looking at the code is necessary. But when you have a much better prompt, essentially you're saving a lot of verification effort after later as well.
I see. Yeah, that makes sense. So what are data threads and how do they improve the management of iteration history in visualization tools like this?
Yeah, so data threads in Data Formulator is for user to basically manage what's their interaction with AI. So this is essentially, you can think, right, just like if you use ChatGPT, you can see all the just like blocks of conversation. So the main challenge data threads trying to address, on the one hand, is of course is navigation to see what they have previously created, and which is not too special, just like because if you're using just like ChatGPT, you can scroll back to see what's going on. But the main thing is following up or backtracking. So in data analysis, right, in an ideal scenario, you always go forward, one question after another, is solve it until you're done. But in reality, everyone wants to know, like, there is always a lot of going back and forth. Okay, I do this. I create a chart to show the average energy for each country, and then realize, oh, there's a country called null. Okay, I need to go back and clean up the data and then go back, right? Or for example, if I create a chart to show the like renewable energy based on just like the total renewable energy use, and then realize, okay, renewable energy is maybe not the best idea because the country who are increasing the renewable energy may also use more like fossil fuel. So it means, okay, I may need to go back and to create a different chart, for example, to visualize renewable percentage. So data threads really provide this power for people to go back in time and to specify either incrementally reusing a previous result and to create something new. So it's essentially had two main benefits. On the one hand, is like when the user select an older chart and want to follow up from that, it provides the AI the precise context of what is the previous chart is created to create a new one. So imagine if you're in a chat GPT kind of like pure like dialogue like way of managing history. I want to say, oh, create something different. But then the AI need to guess which one do you want to build on top. If you guess it wrong, it will build something wrong, and then you say, oh, no. And then essentially describing this context has a big effort. And also the research now showing that when the context is long, it's not AI does not always perfectly retrieve the right memory to help you answer the question. So this is one really benefit. And on the other hand, so this thread is also naturally for iteration. In that when people want to create a editing a chart, for example, going from renewable to renewable percentage, it means my definition of like what is renewable energy is already retained from the previous context, right? So when people going forward in one step, they can reuse a code previously generated, which that code may already we already have some like disambiguation to clarify. So you can reuse that to go forward, and the user specification only need to do the incremental specification on top of the previous one. They don't have to go back all the way and to restart. And essentially those two come together, create a very like Jupyter Notebook style environment for non-coders. Like in Jupyter Notebook, we can go back to a previous cell, reuse a variable, reuse a previous code, and just create something. Or we can use, or we can essentially like fork different branches. Like, okay, we want to after cleaning the data, we want to explore renewable percentage, but also we don't rank country based on the CO2 emission or something. We can essentially create a branch. And one also as so the data threads as a way to visualize the history of the analysis, naturally having this a little bit tree structure here. So it's even a little bit better than Jupyter Notebook, which merge all the context in one long block.
Perfect. Yep, that makes a lot of sense. Okay, and so what are some limitations of relying on AI for generating and verifying visualization results?
Yeah, so on the one hand, we know that AI is never perfect, right? This actually comes in multiple ways. And in fact, I feel when AI just comes out, people are more like kind of try to blame AI, just in terms of, okay, it's just not ability to generate code. But in reality, I would say the AI is doing a pretty good job, especially thinking about like those like basic data exploration tasks, right? Just like we're not writing some crazy logic, we're not writing some like code with a lot of lines. So I think a lot of times the like verification and disambiguation comes from the fact that the user specification is incomplete. Even I'm using I'm using the multimodal UI provided data formulator, my description can still be like sort of ambiguous here and there, right? For example, I didn't specify I want to aggregate the data. And then, okay, the AI may or may not know if the best way to aggregate the data by month or by week or something, right? And essentially, I mean, right now the design of data formulator will just choose one path and go forward, and then this becomes a challenge, right? So this, I mean, if you like aggregate by month or day, it's pretty easier task. But what if you are doing a moving average and a week, for example, like in some COVID case, it's better to do the aggregation by weekday and weekend than the all 7 day, because it may affect like the curve a little bit. So those things can be a little bit trickier to disambiguate, especially thinking the users are not necessarily coders. They cannot just read the code fully and then to understand what's going on and to see what's wrong. And even for us, like, right, when something generates when AI generates a big chunk of code in our code editor, we are just don't bother to read all the details. And so, yeah, so the conversation here is just like really about, okay, how can we help the data analysts understand the solution provided by AI without having them to read the code in detail? So, yeah, and I mean, and you can see, actually, we have a user study earlier that like in the past, we were kind of thinking, okay, maybe data analysts care a little bit more about the chart and data, and maybe like software engineer or programmers who care a little bit more about the program. But in the end, one very fun finding from that paper is that people care about both. In order to trust the result of AI, they need to both feel comfortable about the process, which is code that is used to generate the artifact, which is new data and new chart. They also want to make sure that the code and the data and chart are also right. So essentially, okay, how can we bridge this essentially like the language difference, right? The AI is speaking in terms of code, and the data formulator execute code to generate data and chart, while the user only look at the data. How can we go through this barrier of like execution rendering to understand each other? Yeah, so there's no super easy way. We did our best to essentially try to, I mean, on the one hand, we're a little bit lucky in the visualization domain. Charts oftentimes communicate a lot of the information. For example, if there is outlier may just show up on the chart and people will be able to see. On the other hand, we should have presented data, and now people to actually navigate data with some like sort of basic like spreadsheet style table exploration way that people can sort, can rank, to look into those. So yeah, so from this, if it's a high-level error, people can spot it pretty easily. If it's a data error, and then if, like people can look at the data to understand it. Yeah, but we do still see, even with all the treatment, if the error is very subtle, it's a computation or something, it's not very easy. And one interesting thing from our user study that some participants would say that, in fact, when they try to understand what AI is doing, they don't want to understand every detail. For example, how the AI renamed the fields does not matter, and that which might take 2 or 3 lines of code, right? But they want to be able to have AI to explain the key concept, key computation. So right now, actually, Data Formulator has a code explanation module that essentially translate the Python code into a bunch of like bullet points to summarize what its code is doing, which is some people like it, but most people don't like it, to be honest, because it's a little bit of verbose, kind of looking at pseudocode or something. But one participant was suggesting that it's best not to highlight everything, but to highlight the key computation. For example, if it's calculating a retention value of something, then just explain to me how this value, what's the formula used to calculate, and that should be give them the trust or not. So yeah, so right now we are thinking, how can we actually understand what is the most important message to convey for the user, while user generally would trust that AI would not generate some code, have typo error or something, right? Or some basic error. So yeah, so I think that would be key. It's a challenge, but also an opportunity. It's we solved some, but still a long way to go.
I see. Yeah, that makes sense. And so what does Data Formulator 2 do in situations where maybe the AI generated code fails to compile or throws an error? How do we handle those situations?
Oh yeah, so this is a very good question. So in general, right now, the GPT-4 rarely generate code that fail to compile. Very rare. Every now and then, maybe import a library or something. But often in the past, like if you're GPT like 3.5 or Codex, it's pretty often. But right now, basically, we provide so in Data Formulator, when we assemble the prompt to send to the GPT-4, and it's essentially convey, okay, what is the data fields available, what the data type is going to be, and also we provide a function, basically template that asks you to fill. So basically, given those information, it will never really refer to a field that does not exist or anything. But still, there are 2 possibilities of like the AI to make mistakes. One is that it has a runtime error, because we cannot actually like feed the full data set to tell it, right? So it may not be aware there's some outlier values that it should specially handle. So in this case, we have a repair mechanism in Data Formula 2. So essentially, it's following this like self-repair technique. When it has a runtime error, we feed the error message to the like self-iteration without having user to intervene, and essentially be able to try to repair that. And generally, this is doing a pretty good job. I think this is pretty much also how the code interpreter is doing. Yeah, so this helps a lot. Another type of error is mostly on just like generating a chart that does not render. This is sometimes because the Vega Lite has a specific requirement, right? For example, like a bar chart would not be able to accept certain type of data on x-axis. And yeah, right now, if this happens, we have to have the user to look at it and then to provide feedback to fix it. But we also actually did a little bit of experiment with just using the vision model to try to essentially ask the vision model to look at the chart, to provide some feedback, to revise it. Yeah, so this is you can see it's an extension of the of self-repair, right? In the past, it's only using the execution result as a text to feedback, but now we can also potentially use vision to feedback. Yeah, but one limitation right now is like I think the 4.0 is not doing a super good job understanding what's going wrong in the chart. If it's blank, it's probably okay, but if it's a more subtle thing, it may not like get into the right analysis point. So Yeah, potentially there's some opportunity to actually fine tune the vision model to specifically able to recognize those type of like vision errors.
Interesting. And so how do you envision the future of data visualization tools for users who prefer not to write code?
Yeah, so I mean, I would say like data formula is on that track, definitely. But I think what is limiting a little bit in data formulator is still the full flexibility of like chat-based interaction. I mean, I feel every now and then I'm kind of like torn between two worlds. One world is like it's more kind of like structured. Essentially, user kind of like doing turn, and essentially the tool is doing a little bit of babysitting. This kind I mean, I don't know if it's the right term or not, but more like this help the user to manage the prompt, right? Can delegate the user's interaction with the AI, which I think is good. It's really increasing the reliability. I think that's the key for like non-coder to be able to see more visualization than see more code or more verbose explanation from the pure text, which may not be helpful. So I think this is getting making the result more reliable and more controllable. But on the other hand, it's also like taking away some of the flexibility from the user to provide like free interaction. So for example, if they what if they happen to have in like while creating visualization, right? They suddenly want to ask a question to specifically to change the visualization design, or they suddenly want to just like ask about, okay, maybe I want to clean the data, just clean the data or something just a few steps away, right? And then you can see a little bit flexibility is losing here. So I'm kind of thinking for like the better is essentially what's a better or like even a better way to merge those multimodality UI, so that it's going to be more structured, but also give the user kind of like full freedom. So for example, like if the user wants to like put some like chart editing, oh, can you actually help me add a line to help annotate something? Can you help me change the color scheme or something while they want to actually formulating data, transforming data, right? And also a little bit reminder here is that data formulator is mostly focusing on transforming data. So a lot of the design, those aspects are handled by the user to do it interactively. So yeah, so I think like if we can provide a little bit more freedom in terms of users ask, maybe you want to bring some new data during the chat, or they may want to ask a question, not to create anything, then hopefully the same input box like can still like help them. So I would imagine some new version of the data thread, I would say, in that there's some structured way, either for example, putting data thread as part of the chat interface, or bring some of the chat feature into data thread for like kind of free conversation along the way. Yeah, I don't know what's going to look like, but I think that would be the most important thing.
Interesting. So are there also, so let's say a person is using Data Formulator 2 and they see that something doesn't seem to be quite right, but they actually want to take a look at the code and see if they can figure it out for themselves. Is there a way to do that?
The answer is both yes or no. So right now, just because the data formulator is executing the code on the server, so we don't allow people to edit the code and submit it. It's like a little bit more security issue, so we don't do it. But on the other hand, there's an old feature of data formulator, which is a column-wise derivation. It's kind of concept derivation. It's more like what I mentioned about like extracting mount from data, those kind of stuff. Those are generating a front-end JavaScript code. This feature I don't think is useful anymore, so I didn't mention too much in the new paper. But in that case, it was like generating a JavaScript code. The user can just like edit and see the live update, which is quite cool. Yeah, but I think to be honest, I think the better way for you to actually see the code is probably right now we have an export extraction function. If you click it, they can get the code and extract into a notebook and do something there. Yeah, but I would say that's already a little bit more towards programmers. Yeah.
I see.
Yeah, so hopefully it's a conversation. The fixing error is still better to just tell the AI what to do to fix it. Yeah, in fact, I'm less worried about AI to generate some code to destroy the system than a user to intentionally submit something terrible.
I see. Yeah, I see. So yeah, it probably makes sense that you would not have their ability to actually directly edit the code that's being run, and this probably doesn't even come up that frequently for the typical user for Data Formulator 2, since the typical user is not going to want to get really deep into the code, right?
Actually, it's this is how I thought as well. But actually, from a study, we do find some people who prefer some like quick edits. This is not going to be a crazy edit, but mostly likely, okay, the parameter is wrong. They want to change 5 to 7. It's pretty easy, right? Like they want to say, oh, not aggregate by every 5 days, but every 7 days. They want, oh, but I cannot edit it. So yeah. Actually, one possibility actually related to another piece of work we were doing is called a dynamic user interface. The idea is that when we generate code, we don't just generate a code. We generate a parameterized code that user can edit the parameters, essentially using some sort of like either a drop-down or input box. And so hopefully, for example, if the model is aware something might be like user might want to change, they can like include that as part of the parameter. And then essentially it's a parameter, and then essentially we just like user can edit that and the code can rerun dynamically. So yeah, so I think that could be a solution. Yeah, but it requires the AI to be able to predict. Either we have some way to better understand what are the important parameter a user may want to edit.
Yeah, that makes sense. So do you have plans for Data Formulator 3? And what do you think would actually be included, like if there was another iteration of this same technology?
Yeah, there's going to be definitely. I would say the most interesting thing right now I'm thinking of is like on this data threads aspect. I do think that data threads is a pretty powerful way for you to navigate and manage. So yeah, in Data Formulator 3, I'm a little more thinking about this, like how can we actually unify this kind of free interaction and structured interaction in a way, right? This includes, for example, like what if the user want to both transform data but also change the chart aesthetics? For example, they want to not just want to create a chart to help them understand the data, but also to be able to refine the chart to a way that they can feel very comfortably including their paper or including their presentation. So I'm kind of thinking, is it possible to combine those like multi-directional editing like together, and also in a way that organizing in a very structured way, so people would know, okay, this is new data, this is a new chart, this kind of aspect. Yeah, and I would hope, yeah, adding a little bit more flexibility to handle different types of data, or also even multiple data sets, which is quite common. And also like lowering the friction between the interaction experience and their coding experience. For example, maybe the data thread can be part of the notebook, even for more advanced user to just like to steer their programming or something, right? And sometimes like if we use Copilot too much, our code is all AI generated, but we're kind of lost when we want to edit something. I think this kind of data threads could be a way. Yeah, but I mean, in general, just for data formulator itself, I'm thinking more on flexibility on the specification, and yeah, and a better way to manage history still the goal.
Yep, interesting. Yeah, that makes sense. And so with the Data Formulator 2 as it stands now, how quickly is a user able to understand the tool and get comfortable with using it for their business purposes?
Yeah, so we're planning on. So right now we are releasing it as an open source in GitHub, so people can do it. We're kind of thinking of hosting a public version to encourage people to just to go and play with it. So we have some users like playing with that. Yeah, I do think that just be able to get into it is mostly depending on how much visualization experience they have. If someone already come from a Tableau, this kind of background, or Power BI, they are kind of able to pick up pretty quick because they understand this like view encoding this concept quite well. But for people who are a little bit like not generally from those background, we do see a little bit struggle on just like learning what is this view encoding going to be. And it's funny, sometimes people asking me, is it possible to just hide this like encoding UI to just use natural language? Which I say, yes, possible. So actually, this is one aspect. I think it's possible to flip the order, right? Now, instead of like user to do the encoding, maybe user specifies some abstract, potentially ambiguous input, and then the AI will generate the encoding for them, and then they can update from them. So this is some idea. Yeah, I would say. Yeah, I would say it's like having this, what do you call it, grammar of graphics is a principle behind the Tableau and Power BI. This skill is the most important to be able to pick up and do it. And also like in overall experience using Data Formulator, if someone has more data literacy, is like they know better about data, they know what question to ask, they also have a much easier time than people who don't exactly know what next question to ask when they see a chart, this kind of situation.
Okay, that makes sense. And so I know you were mentioning that this is an open source tool. So, but you were also mentioning how users could potentially use it on the server as well. So, what is encompassed in getting this tool set up, if possible, for them to set them up themselves?
Yeah, so actually it's not too hard. If you just go to the GitHub, the easiest way to use a GitHub code space, and essentially if you just click a few buttons, and then you will set up or automatically as a web tool that is running on the GitHub code space. And also the code space, because it's not paid by you, it's paid by the GitHub repo from us. So I mean, it's not expensive either. So, and then that's an easier way to set up. And also, actually, to me, the best way to do it is to just use pip install, just like pip install data formulator, and then just run like Python m data formulator, or just like data formulator. That will be able to like spawn it. And then the benefit is that the server is running on your computer, and the interface will pop out as a browser, as if like it's a web tool. But you can sort of have a little peace in mind that nothing's really logged. Like to a remote server. We are thinking of hosting a server mostly for people who don't even know GitHub. I think there's a decent population of like the potential target audience never heard of what GitHub is. So yeah, so this is why I think I'm also setting something for those people. But I would say it's already very easy. Just pip install data formulator and run it.
Perfect. Yeah. Yeah, and I could definitely see that if you're targeting non-coding audience, using GitHub, which is like the coding center, could be potentially alienating to a segment. That completely makes sense.
Yeah. The fun thing about CodeSpace is that it's actually very easy, literally just like 2-3 clicks. But between them, it will, I mean, the CodeSpace, it will spawn this kind of like code editor, which I think will scare a lot of people away, even though they just need to wait a few seconds there, but it might just look scary.
Perfect. Yeah, I think that's all the questions I have. I really appreciate you coming on the podcast. It was really interesting to learn more about Data Formulator too. So thank you so much for your time.
Yeah, sounds good. Thank you so much.